This is part 2 of the Chapter 3 video on communicating on local network. So the last part of the chapter, or the first part of the chapter initially, I guess I talked about the TCP/IP reference model and why we actually communicate. So I kind of wanted to pick up with the TCP/IP model and talk a little bit about the OSI model. So with the TCP/IP model, that is a 4-layer model. And as I mentioned, the communication actually begins at the top layer, the application layer, travels down to the transport, internet, and then the network access layers. With the OSI model, we actually have 7 layers. Now, the TCP/IP model is a protocol model, and that is the model used on the internet. The TCP/IP model is a combination of both the TCP protocol and the IP protocol. And a protocol model actually just states what the requirements are. So this is the way it works, whereas a reference model is a reference or a guideline. So for the most part, most computer industries follow the OSI reference model exactly as it's laid out here. If you're looking into Microsoft, for example, so the Microsoft company may have some variations in that, but there are usually minor differences. But if you're looking at your OSI reference model, you will see 7 layers here. Okay. So in layer 7, which is the top layer, the application layer actually is the one that interfaces with the user. So as you're sending something, so you're opening email or you're pulling up a web page and you use the http:// that you enter in when you're typing an address. This would be at the application layer. Okay, so so that would be whatever protocol or whatever application you're using to access your network. That's going to be your connection to the network itself. So that is the application layer, the actual program that you're using. The presentation layer, okay? Notice these definitions are a lot more fancy than what I'm actually referring to. So I'll go back and look at those again in a second. But with the presentation layer, just remember 3 things. So formatting, encryption, and compression. If you can remember that, then that will help you with the presentation layer. As a matter of fact, I'll try to help you by going in and typing some notes. So this might be a little bit helpful when we're looking at each one of these. So let me go back and kind of do that for you. So your application layer. Okay, again, it's closest to the user. Examples of the protocols would be HTTP. Okay, use that when you're accessing web pages. Another protocol would be FTP, Telnet, SMTP, and POP. They are your email protocols. Okay. Your presentation layer, again, just remember formatting, encryption, and compression. So protocols that would be used at the presentation layer would be, say, JPEG files or MPEG files, so for movies. Okay, there's just a couple of the examples. So at this layer, this is where formatting is done as data is sent. When it gets to the other end, if it's been formatted in a certain way, such as the fact that maybe it's encrypted or compressed, it would be decompressed or decrypted at the other end, receiving end. Your session layer. With your session layer, it set up, manage, and terminate the session. So if you've ever received the error message that you lost a session, lost the communication, that would be your session layer. With your transport layer is in charge of just what it says. So transporting something. I mentioned so far as the TCP/IP model, if your job is to transport someone at the hospital, okay, you want to make sure they get from one place to the next. So that's your transport layer. Your transport layer is in charge of getting data where it needs to go. So if you're referring to the TCP protocol, also at this layer, it would segment the data. So it breaks it into more manageable pieces once it's sent. The other thing that it actually does is provide acknowledgments. Flow control and sequencing of data. So what do I mean by this stuff? Okay, flow control. Flow control is decided before data is sent. It's decided between two devices, and specifically the protocol, and it just states that it'll send X amount of data. So I'm going to send however much data, and that is decided upon between the source and the receiver, so that not so much data is sent that the receiving end can't keep track of it. Okay, so the acknowledgments come into play with the receiving end sending an acknowledgment back to the user, and that acknowledgement says, yes, I received frames 1 through 10. So if the sender says, okay, I'm going to send 10 frames at the time, or 10 segments at the time, sends 10 segments, the receiving end sends an acknowledgement back stating that it received those 10 segments, and then the sender knows to send the next 10 segments. Another acknowledgement goes back that those 10 segments were received, and then the next 10 are sent, and that's how you know the information is being sent, and that's referred to a connection-oriented network. TCP uses connection-oriented, which means it notifies the sender that it's going to send something, and it also uses acknowledgments so that both sides know that the data was sent correctly. The flow control is how much of that data is going to be sent at one time, and then the sequencing. The sequencing is where the data may have to travel in different directions to get there if it's broken down into smaller information. So if it gets out of order, if you've numbered it before it's sent, it can be put back in the correct order once it reaches the destination. Okay. With your network layer, the network layer, this is where your IP addresses are. So you have a source and destination IP address. That is routed by using a router. Okay. And the router's goal is to find the best path to a destination. Okay, so a router uses a table, and this table actually lists all the routes it knows about. So think of that in terms of like a GPS. So if you were taking a trip, your GPS needs to know about all the roads that exist along your destination. Same way a router would work, in that it knows about all the roads or all the networks. And so it would consult its little table before sending anything out to another device. So that's your network layer. If you're looking at the data link layer, this is where your MAC addresses actually reside. MAC addresses are found on your NIC, your network interface card. Without a network interface card, you're not going to be able to access the network. Okay. Switches also use your MAC address. Okay. Your physical layer, I'll just put physical. These are the cables that you're using. Okay, and everything is going to be converted into binary, so ones and zeros. So how does this all work together? Okay, if you're looking at this, okay, so you're using one of these protocols mentioned for the application layer. The application layer will be used. It will, so you use the application or go down to your presentation layer where any formatting or encryption or compression will happen. Then at the session layer, this layer will kind of set up the session or the dialogue, communication, however you want to word it, between that device and the end device. Then as your data moves down to your transport layer, this is where your data is going to be broken into manageable segments. It'll be broken into manageable segments. Everything will have numbers put on it. So far as your sequencing of your data, that will happen at this layer. Okay. Then you're going to go down to your network layer. At your network layer, this is where it's going to receive an IP address. Okay. Maybe that data will be routed by a router. receive a MAC address that's attached to it, and then it'll go down to your physical layer. Okay. So as data moves all the way down, it will have headers placed in front of this. Okay. The header will include the information from each of these layers as it goes through. Okay, so here we're broken into segments at layer 4. Layer 3, they might actually be referred to as packets in your curriculum. Okay. Layer 2 is data link, so it may actually refer to frames at your data link layer. You will actually see that right here in the definition. And then your physical layer. So your physical layer, this is where the transmission actually hits the cable, okay, and travels on those ones and zeros. So as you're sending something, all of this information is packed onto the front part of the data, and it is included so that as your data moves throughout a network, that it can find its destination. Okay. Now you'll notice the definitions, the Cisco definitions, are a little bit more complicated than what I've used. Okay, but each one of these should give you some kind of a tip as to what they're referring to. For example, the physical layer provides, the protocol describes the mechanical, electrical, functional, and procedural means to activate, maintain, and deactivate physical connections for bit transmission to and from a network device. That's really wordy, but there's usually a few keys in here that'll help you pick out the definition if you're trying to match it up with the layer that it's in. So if you're looking at this one, for example, electrical, so ones and zeros occur at your physical layer. And then it says something about deactivating a physical connection. Physical connection should indicate your physical layer. Bit transmission, again, ones and zeros. So that should help. For your data link layer, framing occurs here, and that's a common medium. So these addresses, MAC addresses used at your data link layer, they don't go outside your network. These are local. So switches are used locally within a network. Whereas your IP addresses that are assigned at the network layer and routers, they actually work from one network to another. Your key here is identified end devices, so that would indicate an IP address. Transport layer, segmenting, I mentioned that happens here, and reassembling of data, that should be your tip. That is the transport layer. Your session layer provides services to the presentation layer. Well, if you can remember your order, it's going to provide services to the presentation layer because it's the closest one to your presentation layer. Your presentation layer, again, you have this information about application layer services. It services the application layer, so that should be your tip, that it's the presentation layer. Application layer provides the means for end-to-end connectivity between individuals in the human network using data networks. Your human network, so where you interact with the network, is closest to the application layer. I know that's a lot of information, but I'm hoping that will help you just a little bit with some of the content in the chapter. And if you have any questions, please feel free to contact me, let me know somehow or another.